Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of lanes using the Solid Edge software. Coming to the problem statement. A regular hexagon lamina of sides 25 is lying in such a way that one of its sides on HP, while the side opposite to that side on which it rests is on VP. If the lamina makes 60 degrees with HP, draw the projections of the lamina. So, after having read the problem statement, we can arrive at a set of conclusions. The first being the type of the plane that is given to her is an hexagon lamina, and it is a regular hexagon lamina with each of its sides measuring 25 and it is resting on one of its sides on HP. And this side, whichever is there towards the right hand side of the observer, is the initial condition, and the side opposite to this side is the left hand side edge, and this edge is touching VP or it is resting on VP. So this is the condition with respect to the inclination with VP. And however, the inclination with respect to the HP is at an angle of 60 degrees as per the problem statement. So with this data, we shall see how to draft the solution of the problem statement. So now we shall begin with drawing the XY line of thickness 0.18 So let us draw the XY line of any arbitrary length and annotate the line as X and Y, and annotate the reference planes as VP and HP. Now we shall draw the hexagon lamina, the top view of the hexagon lamina on HP, such that two of its sides is parallel to the HP, or rather it is resting on one of its edges on the HP. That would be more accurate. So each of the sides measures 25 So this completes the construction of the hexagonal lamina resting on one of its edges on the HP. So towards the right hand side of the observer, we have taken this edge as the reference. So we can just show that one of the edges, or all the edges, will be measuring 25. It is, since it is a regular hexagon lamina, just showing the dimension of any one side is more than enough. So now we will annotate the corners of the hexagonal lamina. So this is corner A, corner B. So this is resting on its edge AB, followed by corner C, corner D, corner E, and corner F. So we shall draw the front view of the hexagonal lamina by drawing the projection lines from each of the corners, that is from corner B through the corner A, intersect the XY line, from corner C through the corner F, intersect the XY line, from the corner D through the corner E, intersect the XY line. So we will draw the front view of the hexagonal lamina by trimming this portion of the XY line and drawing the front view using the thickness 0.50 Now we shall annotate the front view. So the observer is going to look at the lamina in this direction. So for the observer, the corner B dash is visible first, while the corner A is not visible. So it is A dash inside the bracket. Similarly here, corner C dash is visible first and F dash inside the bracket. And here corner D dash is visible first and E dash is inside the bracket. So this completes the annotation of the front view of the hexagonal lamina resting on one of its edges on the HP, and the reference edge is AB. So with respect to the VP, the edge opposite to this resting edge, that is ED, must be on VP. So we will see that later. So now we will go for the second condition, that is the inclination with respect to the HP, which is equal to 60 degrees. So for that, let us select the front view of the lamina along with the annotations. Ensure the copy is on while you move, keeping the corner B dash A dash as the reference point towards the right hand side of the XY line. Now select the rotate option. So with B dash A dash is the first point of rotation, and D dash E dash as the second point of rotation. Rotate the lamina in such a way that it is inclined at an angle of 60 degrees with respect to the HP. So while doing so, ensure the copy is off. So now this completes the inclination of the lamina at an angle of 60 degrees with respect to the HP. So you can just go for the dimension menu and measure the angle of inclination, which is 60 degrees. So now we shall draw the top view of this lamina. So for this, we shall draw the projections from the corners. So we shall draw the vertical projectors from each of the corners. This is from corner B dash A dash, and draw the vertical horizontal projectors from each of the corners. So from corner A, corner B, corner C, corner D and E, you can extend the same projection lines. So go for extend to next and extend this line so that they are meeting the corner D and E respectively. So now we will draw the top view. So go for the line option, select a line of thickness 0.50 mm. So this is the end point. This is the next end point. Next, the end point of this line, the point of intersection, next point of intersection, end point of this projection line, to the end point of this line from where we started. So just use the zoom option to check if all the inclinations are correct. So now select the annotation, text from the annotation menu, and annotate the top view of the lamina with all its corners, that is A, B, C, D, E, and F. So this completes the second position of the lamina when it is inclined at an angle of 60 degrees to the HP. So now using the trim option, let us trim the projection lines that is not required to us. Okay, so this is done. So now we will go for the next position, that is inclination with respect to the VP. So the problem statement very clearly mentions that the edge opposite to the edge on which it is resting. So if this is the edge resting, that is AB, the opposite edge to that is ED, and this ED is touching the VP. So for that, let us select the hexagon lamina and make it rigid. Click on accept and ensure. Okay, so for this we need to trim the XY line, I mean the projection lines first. Okay, so now we will select the lamina and then make it a rigid set. So now go for extend to next and then redraw the projection lines. Okay, so the purpose of making this a rigid set is the entire entity will be moving as one whole set, and none of the lines will be disturbed even by mistake if the user is going to drag the object. So now we will select this hexagon, the distorted hexagon, in the second position along with the annotation. Okay, so now we will select the move option, ensure the copy is on, and then keeping the point E dash as the center, sorry, the E point E as the center, place E on the reference line. Now go for rotate option, the first point of rotation being the corner E and the second point of rotation being the corner D. Rotate the entire hexagon lamina in such a way that the edge opposite to the edge on which it is resting is on VP, that is ED is on VP. So now the annotations pertaining to the top view shall always be in the horizontal plane. So place this corners in the horizontal plane. So now we will complete the front view of this lamina. So for that, we will select the line option and draw the projection lines of thickness 0.13 mm from each of the corners and draw the vertical projectors. So corner F is here, from corner A through the corner E. So it is intersecting here where A dash is there. And next I shall have to extend this to intersect the projection from corner E. Similarly, from corner B, B is on the XY line while the projection of the corner D is here. So let me extend this till here. and then from the corner C, it shall meet here. So now let us complete the front view of the hexagon lamina by selecting the line of thickness 0.50 mm. So we will take the first base edge, that is AB. From B to the corner C, from C to the corner D, D to corner E, from E to corner F, from F to corner A. So this completes the front view of the lamina. So use the zoom options to check if all the endpoints have been met properly. Okay, so now we will annotate. So this is the corner F dash, while this is the corner A dash. This is the corner B dash. So all the corners pertaining to the the front view shall be above the XY line, that is in the vertical plane. So this is corner C dash, and this is corner D dash, and this is corner E dash. So with this, we complete the front view of the hexagonal lamina. So we will use the trim option to trim the projection lines that is coming out of the front view of the hexagonal lamina. And now we will draw the indication lines using the leader option on the projection lines. So indicate the direction by drawing the arrow marks. Okay. So with this, we have completed the problem. So to sum up, we have got an hexagonal lamina which is resting on one of its edges AB on the HP, and we have drawn the top and front view of the same. And next, as per the next condition, the inclination with respect to the HP is given as 60 degrees. So we are going to incline the lamina at an angle of 60 degrees with respect to the horizontal plane and mark the front and the top views of the lamina. So you can just see that the top view of the lamina is distorted compared to the initial position. And now the next condition with respect to the VP is so the edge which is opposite to the edge on which it is resting. So AB is the initial resting edge, and the opposite edge is the edge ED, and that edge is touching VP. So this you can see here in the third position, the edge ED is touching the vertical plane. And then we have completed the top view of the hexagonal lamina by rotating the distorted lamina in such a way that the edge ED is on VP. And then we have drawn the projections from the front view as well as the top view of the hexagonal lamina and completed the front view of the hexagonal lamina. So how do we validate? In the initial condition, it is resting on the edge AB, while in the final condition, it is resting on the edge A dash B dash in the vertical plane. So with this, we complete the problem. Thank you all for watching.